Second last speaker of the day, second last speaker of today's evening. I'm honored to have Mr. Sai Lin Tu. He is the organizer for the Istio user group, and the topic on which he will be talking is the Istio Ambient mesh in action. So he will introduce himself. A big round of applause for him, and over to you, Sai.
Hello. How do I move the slide? Okay. Hi, thank you everyone for coming. I know today is Friday. It's already 4:45. All right, I'm gonna go for real quick. I only have 30 minutes. So yeah, my name is Sai. I am going to be talking about Istio Ambient mesh in actions and representing Istio User Group Singapore. So Istio User Group Singapore was founded last month and to educate and around what is service mesh in the region. So yep, again, my name is Sai. You can contact me in the LinkedIn, and I started to create some of the small like contents in the YouTube as well. There's my email and also in Twitter. So before we talk about service mesh, we're going to talk about like what's happening in the application modernization space. So we all know that applications are moving towards from monolithic to microservices, and to solve all of these concerns around the costs, CAPEX model moving to the OPEX, and also about the innovations and and also around the increase of velocity of development, that I'm going to resonate with the previous sessions about the project to the product mindset and also reducing the risk. So that is what's happening in the application modernization space. And same time, the way that we build applications fundamentally change from monolithic to microservices. Services are moving from on-premise data center to the cloud, and also building the applications running on the VM instead of running on the containers and running on the Kubernetes. And then, like from the previous talk, project to product mindset, the way that we work changed from the large teams to the agile. This is a sample microservices demo that I just get it from the Google. So if we take a look at it, like I'm going to resonate from the previous talk, from project to product mindset. If we take a look at every single microservices, think as a product. So with that, if we think about every single microservices as a product, there will be a team working on building that product. And so as a result of that, as a team, they can move their own space, own speed, own velocity, and then own innovations. And they may be using different programming languages that they like. So, but what happens is, to complete a task, to complete to make a task complete, all of these microservices need to talk to each other. Let's say, example, in this microservice, this is an online boutique microservices. Let's say if you want to purchase something, and you need to talk all of these microservices together. That's what we call it connectivity, which is networking, right? Application networking. And then what about one of the microservices got security issue or got hacked? How do we gonna prevent, how do we gonna secure that these microservices can talk to these microservices cannot talk to that microservices? And industry terms now, a lot of people are talking about zero trust. How do we secure the microservices among each other? That is one. Another one is around the observability. If you take a look at from the project to product mindset, individual microservices is a product, so you are responsible for your own product, that you're making sure that your microservices, your product is functioning, behaving properly. For example, the request is your apps is super popular and because of whatever reason, and then how you're going to handle how this microservice is behaving. Let's say number of requests, number of loads, right? So how are we going to observe around that? So these are the challenges that we start to face when we break it down, the application from monolithic to microservices. So, this is kind of like a simplified version of that previous slide. So you can see that your microservices, your products are developed using different programming languages. And then again, to complete a transactions, to complete a task, all of these microservices need to talk to each other. So when we start to do that, what are the challenges we face? Number one, these services need to find each other because they need to talk to each other. Second, let's say example, one of the microservices, the load is high. How are we gonna balance the load around the load balancing? And sometimes, if you remember about the fallacy of distributed computing, network is not reliable. So how do we solve those networking issues around this timeout, retry, circuit breaking, around that? And also, what about the observability that I talked about earlier? Right? So these are the challenges that start to face when these microservices need to communicate each other. So how do we do in the past? So developers use specific programming languages, libraries, to implement all of these embedded into their code, right? So, but if we think about it, developers are best spend time writing code for the business logic. Developers' job is not to do all of these infrastructure functionalities, right? So these are the challenges that start to face. We call it application networking challenges. How do we do that? One of the most computer science powerful concepts, abstraction, right? So how do we do is we abstracted all of these functionality, the challenges I talk about, abstract it into another layer, right? We call it proxy. In a Kubernetes term, we call it sidecar. So if you take a look at it, all of your products written in different programming languages, developers just focus on the business logic. That's what they are good at. And then all of these infrastructure concern, abstracted into the sidecar proxy. So if we zoom in, that sidecar proxy is in the Istio context. We leverage Envoy proxy, which is open source by Lyft. And if we zoom in that sidecar proxy, these are the functionality that's available, including layer 4, and then as well as a layer 7, and all of these different protocols like HTTP, HTTP 2.3, gRPC, and a lot of stuff available, right? So, and all of these, let's say if your application have 10,000 microservices, you will have 10,000 sidecars running along your applications. That's a cost, right? Your sidecar needs CPU and memory, right? So, and then all of these functionality of the sidecar will be controlled by the control plane. We call it service mesh control plane. And then this, we call it service mesh. The service mesh technology is an open source by Google, IBM, and Lyft around 2017. And then now have a lot of vibrant communities supporting and contributing that service mesh Istio. Now Istio is officially graduated not long ago from the CNCF. A lot of production customers out there, and you can check it out. Who are the Istio customers? Who are the companies running Istio in the production today? But as I mentioned earlier, there are challenges with the sidecar proxy. Number one is around operational complexity. What does it mean? If every microservices need to have a sidecar. Let's say today, if you don't have the Istio running, and if you introduce the Istio, you need to restart your application code, the container. That is around operational complexity. Second one, obviously, Kubernetes sidecar is not a first-class citizen for Kubernetes until recently, right? So let's say, example, if you have the Kubernetes jobs up and running, the Kubernetes jobs run, and then complete. But the sidecar is always up and running. But let's say, example, if you have a job in your environment, there will be a lot of sidecar running and hanging around, right? So that is one of the another application reasons, like application mesh doesn't aware of it. And then the third is around, obviously, latency. Without sidecar, it's a zero latency from the one app's microservices talk to another microservices directly. Nothing involved. But with the sidecar introduced, you see there is, from the application, not talking directly to another application anymore. It talks to the sidecar, to another sidecar, to another, and then applications. That is within the node. What about across the node? What about across the clusters? Another challenge is around the cost, right? Every sidecar is cost, right? And CPU and memory require. So these are the challenges with the traditional sidecar-based approach. So we get the benefits of service mesh is still running, but there's always a cost that we pay for it. So introducing ambient mesh, which is a sidecarless architecture. 2022, around September, I guess, Solo and Google worked together and then contributed another sidecarless data plane approach and contributed to the open source community. Yep, so this is 2022 Istio Ambient Mesh launch, and now Istio version 1.18 is a GA now, and you can start testing on your environment. So the fundamental difference is obviously instead of like a per pod per application, there's a proxy running, and then it changed to the per node. So a lot of things is 90% like optimized. So you can see, let's say example, one node, like if basic functionality, you can run 110 pods, and then one node, if you run 110 sidecar for your microservices, instead of 110 sidecar proxy, you need a 1. Yep, so obviously, reduce costs. And another one is around simplifying operation. This is one of the important things. In the sidecar approach, when we introduce sidecar, you need to restart your applications. But with the sidecarless approach, that application doesn't aware that service mesh exists, which is transparent, right? So you don't need to restart your applications. So that makes an application to onboard to the service mesh more easier, more simplified, and then you can start to do leverage and enjoy the benefits of whatever this service mesh provides. Okay, so how do we do that? If you remember that sidecar, if you zoom in, there are a lot of functionalities, layer 4 and layer 7. So what we did is we just split that functionality sidecar into 2 different layers. One is around, we call it L4, secure overlay layer. Another one is around L7, layer 7 processing layer. So if you remember traditional, like a fundamental networking OSI 7 layers, right? From the physical to the data link to, layer 3, TCP, IP, and then all of the layer 7, right? So in the secure overlay layer is focusing on, if you take a look at the observability stacks, right? It's around focusing on TCP. So that means the processing is not all the way to layer 7, so a lot cheaper. And then you can definitely get the MTLS. So zero trust MTLS. So one of the business drivers for companies adopting Service Mesh Istio is to implement the MTLS functionality among the microservices. So you already get the out-of-the-box MTLS functionalities, and then of course this traffic management around the layer 4. But not every application needs layer 7 functionality. But let's say if you need a layer 7 functionalities, and then you can start to use this layer 7 functionality, so with that, you can achieve layer 7 related observability metrics and security, of course, layer 7 and security. With layer 3, 4, you can use based on the IP and port, With the layer 7, you can have the security based on the TCP headers and whatnot. Around layer 7, you can route based on these HTTP layer 7 headers. So this is a fundamental change in the sidecar-less architecture. So obviously, another around performance, of course, no mesh, no problem. So 0 millisecond, right? And then if you take a look at L4 and L7 processing times, L4 TCP layer is you only process it to the L4, 0.5 millisecond. If you need L7 all the way, you need 2 milliseconds. So mesh sidecar, if your applications only need the layer 4 functionality, just need the MTLS, which is 1 millisecond. L7 sidecar, which is 4 milliseconds. And the ambient mesh is L4, 1 milliseconds, and ambient mesh with L7 is only 3 milliseconds. I don't really have a demo, but I demo and I screenshot and I capture it. It's pretty simple, pretty simple to start. So you have your Kubernetes cluster up and running, and you have your deploy the simple microservices demo that I shown earlier. And then what you need is now Istio version 1.18 alpha. Its ambient mesh profile is available already. So you just need 2 commands to kickstart and test your ambient mesh. And then the moment you're done, that Istio Cuddle install profile ambient, and this is what you're gonna see. So another way to test is you just run Istio Cuddle install profile, demo profile, and the ambient mesh profile. You use the kind cluster, and you compare what are the components that install with demo profile default sidecar-based architecture, and then ambient mesh architecture. That is how you can compare. So if you can see that there are 2 components that introduce here, Z tunnel, we call it zero trust tunnel, and then the Istio CNI mode. So Z tunnel run as a daemon set. So because of its daemon set, every node in your Kubernetes cluster will have the Z tunnel running. So running Z tunnel as a daemon set is intentional. Then I'm going to explain in the later slides about why we do that. Z tunnel is eventually responsible for redirecting the application traffic to the zero trust tunnel. So there are 2 options available to run as the Z tunnel. One is the IP tables and Genevieve overlay tunnels. If you are a traditional network engineers, you're familiar with the VXLAN and Genevieve, all these kind of tunneling technologies. So that is around that. Another option 2 is the eBPF-based traffic redirection. So again, another one is the Istio CNI node running as a daemon set the moment you install. Again, that Istio CNI node is port checks whether all of your microservices are part of the ambient mesh. That's what it does. And then again, it's gonna talk about it will redirect the traffic, application traffic to the Z tunnel, right? So you can think in the 3 steps. One is your applications, microservices running on that, and then if it is part of the ambient mesh, it will redirect to the Istio CNI node, and then Istio CNI node redirect the traffic to the Z tunnel, and then that Z tunnel talk to another component, Z tunnel, Istio CNI, and then another application. So you can think about that as a mental model. This is it. So it's ambient mesh architecture. Your application, there is no sidecar running right now. So now you have this 6 applications running on 2 different nodes. And you have a Z tunnel components running as a daemon set on all of your nodes. And when the application talk to the another applications, either on this within the same node or across the node, it will talk to the Z tunnel. That Z tunnel will establish an MTLS connection. Under the hood, it uses SPIFFE, SPIFFE, Secure Production Identity Framework of everyone. That SPIFFE as your identity. And then after that, it will talk to another Z tunnel, and then it talk to your applications. So this application doesn't, now the sidecar is gone. So if we take a look at zoom in, what if your application need layer 7 functionalities? I talk about you need another component, which is you're going to spin up on demand. You need we call it waypoint proxy that will provide a layer 7 functionality. So again, your application talking to the Istio CNI node, and then that Istio CNI node talk to the Z tunnel, and then the Z tunnel talk to the waypoint proxy to have the layer 7 functionality, and then it will talk to Z tunnel CNI nodes, and then your another microservice. So to get a high-level overview picture, you can see here. This is an important slide. You will have your Kubernetes cluster, all of your applications running on different nodes. The Z tunnel, which will provide your MTLS functionality, zero trust, secure overlay layer, running on all of the nodes, and all of these controlled by the Istio control plane. And then you will have the waypoint proxy layer, which will provide you layer 7 functionalities. So your Z tunnel and the waypoint proxy functionality, the behavior will be driven by control plane, Istio-D, the same way that Istio sidecar architecture works. So, another representation again around your service. This is C1, I call it a client service. This is called service. At the end of the day, these are microservices. And then talking to Z tunnel, and then Z tunnel talk to establish an MTLS connection. We call it HBone protocol. I'm going to talk about that later, a little bit detail. And then all of these Istio-D will configure all of this Z tunnel behavior through the ACS conf API, which is Envoy proxy. So again, this is a Z tunnel, the HBone overlay. So if you take a look at it in the how is it likes for the detail, you can look at this detail blocks by Solo. And this is what is it like, the HBone protocol, HTTP HBone overlay we call it. So to recap, just nice. Why we adopt Istio Service Mesh? There are a lot of reasons. This isn't an exhaustive list, right? Fundamentally, what we need is around the zero trust architecture for security among the microservices. Second point is around the observability, right? So the Istio, the data plane generate a lot of traffic, the number of requests, total number of requests, what is the latency likes? Observability. Another one is around traffic management, right? So you can do the A/B testing, canary deployment, and some other traffic management features that are available. And then another one is around resiliency, really limiting, circuit breaking, and timeout. So these are the key business drivers for adopting Istio, either sidecar-based or sidecarless-based. So I came up with this slide when I was trying to explain to my non-technical people. So life before service mesh and life after service mesh. So life before service mesh, developers write your microservice application, focus on the business logic. In your microservices, you include all of this security, traffic management, observability, resiliency, logic, using this application-specific library, either Go, Ruby, Java, Python, and whatnot, right? So you put all of these things into the code along with your business logic. As a result of that, it's managed by developers. Multiple tasks, multiple frameworks, and also language specific. Let's say example, if you have your microservices, 100 microservices, writing in 7 different programming languages, and then let's say you write in Python and one of the library have some problems, some security issues, and you need to patch and you need to update. So the whole microservices you need to fix. And after service mesh, that is one of the reasons. After service mesh, what you do is we break it down to 2 components, right? Developers, managed by developers, just focus on the business logic. That is what they are good at. And then all of these logic, security, traffic management, observability, resiliency, hand it over to the service mesh layer, which is the infrastructure layer, and let it managed by the service mesh. So this is the life before service mesh. This is after service mesh. If you don't remember anything today, just remember this slide. Yeah, so I just make it a little bit like a techie. With the sidecar architecture, you will have all of your applications running on Kubernetes clusters. We'll have every single application have a sidecar, and all of these sidecar will be controlled by the Istio. With the sidecarless architecture, you have the Z tunnel on every single node. That's all for layer 4 functionality. And then you will have the waypoint proxy is on demand. If you need it, you just spin it up. If you don't need it, don't spin it up. So it costs a lot, it saves costs, and it's simplified a lot, right? You can see the difference, this and this. If you want to learn more, go to the academy.solo.io. They have, solo.io have the hands-on lab with the step-by-step guide on the Istio traditional sidecar-based approach and the sidecarless approach. And then, again, you can join the Istio user group here, and then we just kicked off last month, and we're gonna be coming up in the future upcoming months. Once again, thank you all very much for your time, and hope you learned something. And this is my contact if you want to reach out. Yeah, just nice. Thank you very much.
Thank you so much, Sai. It was a wonderful presentation, short and sweet, and quite detailed, of course. And I'm sure, audience, there are loads of takeaways from track 2. So I have the honor of felicitating him